This is the third video on Year 2 integration. This is when you have to use Trig identities to do the integral. If you look at the questions on the left here, all these integrals we've seen before in the previous videos, so they're all fairly straightforward. Also, questions like this where you have to integrate sine 2x, we've seen those before. That's fairly straightforward as well. That's just minus a half cos 2x, and the integral of sine 3x is very similar. But if you have to integrate something like sine squared x or cos squared x, that's a bit more difficult. So you might want to just have a think, how would you go about integrating sine squared x? The way to do it is to use one of the double angle formulae. If we can replace sine squared with a sine 2x or cos 2x, then that's good because those are both easy to integrate. So the double angle formulae that's going to help us here is this one. The one with cos 2a is 1 minus 2 sine squared a, because if we rearrange that to get sine squared on its own, we'll be able to integrate cos 2a very easily. So let's rearrange this then. If we get sine squared a on its own, we'll get a half minus a half cos 2a. That comes from just adding that over there, subtracting the cos 2a to the other side, and then dividing everything by 2. So now let's replace this sine squared with this. We've not integrated yet, so we still need the integral sign there and the dx. So we've got this now. Obviously we need to replace the a's with x's. And we can integrate this fairly easily. Now the integral of a half is a half x. The integral of cos 2x is just going to be a half sine 2x. And don't forget the plus c. So the final answer is half x, or x over 2, minus a quarter sine 2x plus c. Let's have a look at a few more questions like that. Now, all of these questions on the left, all of the integrals on the left, like this one, the answer's directly opposite on the right hand side. So the integral of sine squared, we've just done it, it's this. So what you need to do with these questions is think, how do I go from the question on the left to the answer on the right? You've got to kind of think about how do you do the working out in the middle. So the first one we've just done, we changed this to a half minus a half cos 2x, and then we just integrated. Okay, so we've done the first one. So you might want to just pause the video and see if you can work out how to go from the next one, so cos squared, to this. So this question, the second one, again, we're going to need to use a double angle formula here. I'll put the double angle formula and the trig identities on the right hand side. Also, these are useful as well, particularly the highlighted ones that are in the formula book. So which of these double angle formulae are going to help us here? We need to somehow change cos squared into either a cos 2x or a sine 2x. The one that's going to be helpful is this one. So cos 2a equals 2 cos squared a minus 1. Now rearranging that, what we can do is get cos squared on its own. So if we get cos squared on its own from that, we will get a half plus a half cos 2x. And we haven't integrated yet, but it's easy to integrate now. And we'll get this. The integral of a half is half x. The integral of this is this. So it's very similar to the previous one. The next question, we've got to integrate tan squared. Now I don't think the double angle formula are going to help us here. This one here is going to be difficult to rearrange to get tan squared on its own. So I don't think that's going to help. But what will really help is to get tan squared in terms of sec squared, because sec squared is easy to integrate. It's in the formula book there. So we can use this. We can use the fact that tan squared is sec squared minus 1. Oh, sorry. Tan squared is sec squared minus 1. And now if you integrate sec squared, like it says down here, we'll get tan x. If you integrate minus 1, you get minus x. The next one, the sin x cos x, that it's not obvious at first what to do with this, but sin x cos x does look like this here. It looks like sin a cos a. So what we can do, since sin 2a equals 2 sin a cos a, if we half that equation, so I just moved that up there, if we half everything, we'll get a half sin 2a equals sin a cos a. So that's useful because now if sin a cos a equals a half sin 2a, then that means that sin x cos x is going to equal a half sin 2x. So let's replace this with a half sin 2x. And now that's easy to integrate. We integrated sin 2x at the start of the video, and when you times it by a half, you're going to get minus a quarter at the front. So that's that one done. Now the next one, you can see, looks very similar to the one we've just done. It's just that instead of x, we've got 5x here. Instead of this x, you've got 5x as well. So we can use the previous one. We can use the previous identity, but instead of the x here, we just need to swap that for a 5x. Okay, so we'll put a 5x in a bracket here. Okay, so it's the same as the previous question. We're just replacing all the x's with 5x. So we end up integrating. We need to integrate a half sin 10x, which is easy to do. Integrate that, and you're going to get minus 1/10 of sin 10x. So multiply by half, and that's where this answer comes from. The final one, I'll do the working out underneath it here. It's not obvious what to do at first in terms of sec x and tan x, because it's not a sec squared and it's not a tan squared either, but we can multiply out the brackets. I think that's going to help us out. So let's try expanding the brackets and see what that gives. We still won't have integrated, so we still need the integral there. If we do that, we're going to get sec squared x plus 2 sec x tan x plus tan squared x dx. Okay, so that's just expanding the double brackets, and what we can do now is just integrate all of those because they're all fairly easy to integrate. You can see that the integral of sec squared is tan x. The integral of this sec x tan x is here, it's just sec x. Got a 2 in front of it though. And the integral of tan squared, well, that's pretty good because we've just done that one. So we've just done the integral of tan squared up here, and we know the answer is this. So we can just write that down since we've already done it. And don't forget your plus c because we've now integrated. So if we add the two tan x's together, we'll get 2 tan x plus 2 sec x and minus x plus c, which is what it says over here. Here's a couple of questions from exercise 11c. Question 1, there's quite a few tricky questions in question 1 in exercise 11c. I think this one's particularly difficult. We want to integrate this. I suggest changing this to look like this, so it's sine x cos x all squared, and then you might recognize that that is similar to one of the previous questions we did. We did do the integral of sine x cos x before, and so that can now change. That will be the same as doing the integral of half sine 2x all squared. Okay, so we came across that before, and that is just by using the double angle formula for sine 2x and halving both sides. So now we can expand those brackets, and that will give us 1/4 sine squared 2x dx. Need a lot more room than I thought for this one, so let's just move this down. So next we can 1 divided by 1/4 is 4, so let's put the 4 on top. So actually this question we want to integrate 4 over sine squared 2x. Now always be on the lookout for getting one of these. Can we get a sec squared? Can we get that? Can we get that? Or can we get that? Now you might have spotted that the one we can get here is that cosec squared. So this question will now become the integral of 4 cosec squared 2x, because 1 over sine squared is cosec squared. We still haven't integrated anything now, but I'm pretty confident you'll be able to do the rest now. You just integrate cosec squared. So if we do that, we'll get, so when we integrate this, we're going to get from here, we're going to get minus a half cot x, sorry, cot 2x. And don't forget we've still got the 4 there, plus c. So the final answer is going to be minus 2 cot 2x plus c. Let's just do one more question from exercise 11c. Let's do 2a. So this one, I think I would start by splitting this up into separate fractions. So it's 1 over cos squared x minus sine x over cos squared x. The reason that's helpful is because this is going to give us a sec squared x, which is easy to integrate. It's just tan, and this doesn't look very easy to integrate until you realize that that is going to give you that's going to give you sec x tan x. So sec x tan x. If you're not spotted why, that is because this is the same as sine x over cos x which is tan x, times by 1 over cos x, which is sec x. So that is there, and that is sec x. So we just need to integrate this now. If I just remove this, so if we integrate all of this, the integral of sec squared is tan x. It's all in the formula book. So we're going to be using this one and this one. So we're going to get tan x and sec x. Whoops. So the answer we're going to get is tan x. Sorry, we've integrated now. So we're going to get tan x minus sec x plus c. And that's the answer to 2A.